Hey everyone, today we are going to solve the LeetCode question, find all numbers disappeared in an array. Okay, I'll show you two solutions. The first solution actually doesn't meet follow-up question, but it's a good idea to think about multiple solutions for your interviews. So in this problem, we are given array of integers where each integer is in the range from 1 to n. Our goal is to find all integers that does not appear in the array. When you first encounter this problem, the most straightforward, brute force method is to check every number from 1 to n and see if it exists in the input array. However, checking existence in the list results in O(n) square time complexity, which is too slow for larger input. So question is, how can you make existence check faster? My strategy is to use set. So in Python, searching for element in set takes O(n) time on average. The trade-off is by converting the list into set, we use a bit more memory to gain a massive boost in execution speed. Okay, I'll explain step-by-step algorithm. Actually, it's very simple. So first of all, we convert this input array into set so that we can remove duplicate numbers like 3 or 2. And in the end, set will have 4, 3, 2, 8, 7, 8, 1. And after we create a set, just iterate through from 1 to n. So n is the length of the input array. So 1, 2, 3, 4, 5, 6, 7, 8. So we iterate through from 1 to 8. And every time we check set, and if we don't have same number in set, so that is like a missing number, disappeared number. So that is one of target numbers. So before we iterate through like 1 to n, we create result variable. So this is array. And then check from 1 to 8. And first of all, we are 1. So let's say n equal 1. And we have 1 in set, right? So 1 is not target number. And how about 2? And we have 2. So 2 is not number. And 3, we have 3, not target. 4, we have 4, not target. And 5. So we don't have 5 in set, right? So that means 5 is a disappeared number. So add 5 to result variable. And how about 6? We don't have 6, right? So 6 also disappeared number. So add 6 to result variable, 6. And how about 7? We have 7. So 7 is not target. And 8. So we have 8. So 8 also not target. So in the end, we just return 5 and 6. Yeah, so that is a basic idea to solve this question. So let's jump into the code. Okay, let's write the code. First of all, create a set. So let's say numbers equals set and nums. And we create a result variable. This is array. And let's iterate through one by one. So for n in range. So from 1 to length of nums plus 1. And then if n not in numbers, so that means current number is one of target numbers. So the current number to result variable. So less dot append and n. After that, just return result variable. Yeah, so let me submit it. Yeah, looks good. And the time complexity of this solution should be order of n because we iterate through like from 1 to n number. And the space is also order of n. We use set, and if all numbers are unique, length of numbers is same as input array. Yeah, so let me explain the second solution. If you solve this question using a set, an interviewer might follow up with deeper question, like, can you solve this without using extra memory? While set-based approach is intuitive, it requires additional space. This alternative solution achieves O(n) space complexity by using technique called in-place marking, where we treat input array itself as our record-keeping board. The crucial hint in this problem is that the numbers in the array stay within the range of 1 to n, This perfectly corresponds to the array indices from 0 to n-1. If we encounter the number 3, it corresponds to index 2. So we can ask ourselves, like, can we make the value at index 2 as a scene without losing original data? My strategy is to make the original number negative. Okay, let's look at how this algorithm transformed array using input. So basically, we iterate through all numbers one by one. So first of all, index 0, and we found 4. So this 4 corresponding to like index 3, right? So calculation should be like 4 current number minus 1 equal index 3. And check index 3, 0, 1, 2, 3. And we have 7. So just convert 7 into minus 7. So we will multiply minus 1. And then 7 is now minus 7. And then move next. We found 3. So 3 is corresponding to index 2, right? So formula is 3 minus 1 and index 2. So 0, 1, 2 here. And we convert 2 into minus 2. Looks good. And move next. Actually, here is a problem. When we are index 2, we hit a snag. The current value of index 2 is already negative number because we just make it negative in the previous step. If we try to calculate index normally, so we will get minus 2, minus 1, so we will get minus 3, right? This point is like nums minus 3 is like element from the end, right? Like here. But we want like 2 minus 1 and index 1. And we want to change 3 into minus 3. So let me summarize current problem. So the problem is that once we overwrite the value with negative sign, the original positive value seems to like disappear for future iterations. So how can we avoid this problem? My strategy is to use absolute values. The issue is that when we reference value in the loop, they might have already been flipped to negative numbers. We are using negative sign as a flag to check existence, but we are not actually changing the underlying number. I mean, 2 becomes minus 2, and 7 becomes minus 7. By taking an absolute value of minus 2, we get back to the original number 2, right? Or like 7. So this allows us to retrieve the original data even after it has been marked, right? So at index 2, we already have minus 2. But if we convert minus 2 into like absolute value, we will get 2. So that's why these numbers are like an absolute value and minus 1. So we will get correct index number, right? So in this case, 2 minus 1 is 1. So we will find 3 and convert 3 into like a negative number, like minus 3. And we will do the same process. So move next. So 7 is already minus 7, but we use absolute value. So that's why 7 minus 1 is index 6. 0, 1, 2, 3, 4, 5, 6, and convert 3 into minus 3. And then move next, 8. So again, so we use absolute value. So 8 minus 1 is 7, I think here. And then convert 1 into minus 1. And move next. So 2. So 2 minus 1 is 1. And check index 1. And we already have a negative number, so we don't do anything. And then move next. So we found -3, and using a absolute value should be like 3, -1, and index 2. Check index 2. We already have -2, so we don't do anything. And then move next. We found 1, so 1 minus 1 equals 0. So check index 0. We have 4, so that's why we convert 4 into -4. And then finish iteration. Now the setup is complete. We can easily find the missing number between 1 to n. We simply loop through nums one more time. Any index containing a number greater than 0 means that index was never marked. So in this case, the positive values are index 4 and index 5. So that means, so this is index number. So don't forget add +1 before we return the numbers, because when we convert real number into index number, we add -1, right? So that's why don't forget add +1 before we return the target numbers. So 0, 1, 2, 3, 4, index 4 and 5 means 4 plus 1 is 5, and 5 plus 1 is 6. So these are like a disappeared number, so we should return 5 and 6 in this case. That is a basic idea to solve this question, so let's jump into the code. Let me quickly introduce my membership. There are 4 levels, and with the first time offer for Ninja, which is 90 yen, so this is like a 57 cent US dollar at today's exchange rate. So with the first time offer for Ninja, you get ad-free access to all medium and higher level videos. At the Buy Me a Coffee level, you will also unlock extra content, including infrastructure-related videos. Any level of support means a lot and is greatly appreciated. Your support helped me keep this channel going. Thank you so much. Okay, let's write the code. First of all, we make the numbers negative. So for I in range length of nums, and then so index equal, as I told you, we use absolute value and numbers and the current value -1. And we will get index number. And if numbers index is positive, in the case nums index multiply equal -1. And then after that, we create a result variable. So this is array. And then for I in range and the length of nums, and if current number is greater than 0, I mean positive number, in that case, that index number is disappeared in the array. So add result variable with +1. So append and current index +1. And after that, just return result variable. Yeah, so let me submit it. Yeah, looks good. And time complexity of this solution should be order of n, and the space is O1 because we use input array itself. So we don't use extra memory such as set. Yeah, so that's all I have for you today. Please support me with the actions such as comment and hitting like button. I'll see you in the next question.